Hi, Ben with Novolux Stereophonic. Thanks for stopping by the channel. At the bench here I have a quad 33 preamp and a quad 303 power amplifier. These are on the bench courtesy of my friend Pedro Diaz. He has a YouTube channel as well. I'll leave a link to that in the description in case you want to check it out. And the reason these pieces are up here is because him and me worked out a trade. He has a very rare Kenwood amplifier called a 700M. I've had one in the past, but it was in rough cosmetic condition. I've been looking for a minty one, and he has one that really fits the bill. So we worked out a trade where I'm going to service some of his electronics, and that parts and labor cost is going to go towards that beautiful Kenwood, which will appear in a future video. So in this video, I'm going to be servicing these two pieces. This is going to be my very first time working on a piece of quad equipment, so you'll be coming along with me and learning as I go. So if that sounds cool, stay tuned. We'll get these things taken apart, diagnosed, and serviced. I'm going to start out with the power amp. I prefer servicing power amps. I really like working on them, so I thought for my first quad piece I might as well start with the amp. On the back here we have a proprietary power connection and DIN for the input. I'm going to go ahead and open this thing up. We'll do a physical inspection before I attempt to power this thing on and test it. It looks like removing the bottom cover is the first order of business here. Missing a screw there. Or a foot. It's possible that the foot was supposed to be installed here. We'll find out here in a second. Okay. Yeah, that looks correct. So that foot position is correct. I'm just missing one screw. It goes into the chassis here. We'll set this aside. And now I have access to some screws here, which should be able to allow the top cover to come off. It's like an interesting PCB design. Okay, let's see if that allows the top cover to come off. Getting there. There we go. This cover does have a slight deformation. I may be able to pound that out. From the top, this looks super basic. We have a capacitor bank. I don't know why this one's all janky. It's kind of pushed off to the side. The clip might have got bent or something. Our input wiring, it's nicely loomed there. Power transformer. Looks like maybe 4 output transistors on this heatsink. There's a cover here that I can pull. And then the power supply circuit and driver board and stuff must be down here. So I'm going to investigate this a little bit and get it kind of torn down so that I can see what's in there. I'm thinking that by removing these screws I should be able to flip down this heatsink and take a look at what's going on there. From this angle I can really see this transformer is really, really dirty. Let's see, 1, 2, 3, 4, yeah, it looks like 4 output transistors, so that should be 2 channels and push-pull. All right, that's that. I need to get under here and see what type of components are on those 2 boards. So it looks like these boards are just held in with some clips. I always want to be careful with something like this because it's really easy to snap old plastic parts. A lot of times they can get really brittle, so I'm just going to gingerly pry and lift this board out. There's 1, 2, okay. Almost there. Okay, this board's free. Must be some heat sinks on here where those screws are. Wow, this thing's going to be a dream to service. Everything just flips right out. Okay. These caps are suspect already. I've never seen this type, but they just look like caps that are going to fail. They're electrolytics. Let's flip this other one up. Oh, it's an identical board, so this must be left and right channel. And we probably have DC offset and bias adjustment, and they're accessible through some little holes here. So pretty cool device. Really, really simple and very well made. Super serviceable with these harnesses like this. This thing's gonna be a breeze. I'm guessing this is just some sort of rectifier for the power supply or something. Let's pull this one out too. Looks like a regulated power supply, probably adjustment there. Little control transistor and a pass element. So super, super basic stuff. All right, I'm going to kind of put this back together enough that it can run, and we'll see what its current condition is and see if there's any issues that we'll be trying to tackle during this service. This thing looks all original at this point. Okay, so I just clipped this side back in, and look at this. This is going to be just a dream. I'll leave these connected, and I can just tip these up, replace any parts proactively that should get replaced. I've got access to the main filter caps. This is going to go pretty quickly probably. I'll get this screwed back in, and we'll give this thing a quick baseline test. Whenever working on equipment that was produced overseas, it's always important to check to make sure that it's configured for 120 volt operation before testing. So looking at the plaque here, this does say 120 volt AC, and I'm wondering if this is something that might be a plug where you remove this plate and you can change something. So I'm going to take a look over there. It looks like this is just an opening, a circular opening on the other side of that plate. So I need to take a look at the power transformer to make sure that this thing's going to be properly configured. Can't always trust the sticker. It looks like the power transformer is protected by a little plate down here. Actually, you know what? Let me just put this back on its side. I should be able to get in there with all these boards folded down. And this amp is so simple, I could probably service it without a schematic, but just so that I know what I'm supposed to be adjusting this regulator for and other things, I'll be taking a look at the manual here just to give myself a little bit of knowledge before I start digging in here. Again, I'm only going through this step because this is a British-made device, and I think it's a good example for this type of explanation. This came from Pedro's place in an operational condition. I know he was running it on 120 volts. It has a 120 volt tag, but just to confirm, let's look at how the wiring is done. So we have our AC mains input here. One of the wires goes straight through this blue sleeve and into the power transformer. The other one goes up here to a 2 amp fuse, comes back down through the blue sleeve, and then arrives here as well. And then it looks like this is a dual primary transformer, and this input is paralleled together. If this was wired for 240, it might look a little bit different with some of these taps series together instead of paralleled. So I'm going to look up the schematic. Hopefully there's a diagram of the various power transformer configurations, and that'll be the easiest way to confirm that it is indeed a 120 volt wired unit. So after taking a close look at the schematic, I realized that I made some incorrect assumptions about this amplifier. I'll go into that in more detail in a bit, but for right now, let's take a look at the power transformer. So right off the bat, you can see this little socket here. And this looks like a multi-voltage selector with various options for selecting voltages for different regions around the world. Our unit has that section blanked off and there's nothing there. That was that little circular hole in the back of the chassis. So my guess is this was a US only version. They killed the multi-region switching and just wired it straight for 120. But the way that we're going to confirm it is by looking at the positive supply voltage here. So that's supposed to be plus 67 volts. I'm going to ramp it up slowly on the variac. Once we get to around 116 volts or so, that should read around 67 volts DC. If it was wired for 240, 220, something like that, your voltage would be about half of this. So that'll be a easy check for us to do. Okay, let's talk a little bit about the incorrect assumptions that I made about this amplifier. So when I first opened it up and I saw these big green capacitors, I assumed they were all power supply filters, maybe plus minus rail for this channel, plus minus rail for that channel. That's not the case at all. So this power supply is a single rail supply. It has plus 67 volts and that runs the whole amplifier. These two capacitors are actually wired in parallel, making up one big composite capacitor. So hypothetically, this could be replaced, these two could be replaced with a single part. These two are the audio output capacitors. So in this type of design, the speaker output sits at half the rail potential. So in this case, somewhere around 33 volts or so. And that needs to be isolated from the speakers or you damage the speakers. So that's what these capacitors are for. And when we replace these, we won't necessarily replace them all with the same value because these are in power supply service and these are in audio coupling service. And the value that you choose here determines the low frequency roll off. So that's something interesting that we'll get into later on. And then going along with that, I had assumed that one of these trimmer adjustments would be for DC offset, but in this type of design, which is called a quasi-complementary capacitor-coupled output stage, that's going to be the DC balance control, which allows you to sit the center of the speaker right in that 33 or so volt range, halfway between the power supply rail. Now to do this initial power supply test, I have to make sure that these boards are insulated. If this swings down and any of these contacts make contact with this metal here, it could be pretty catastrophic. So I either need to completely remove the boards and dangle them down or put something in there as an insulator. So let's see. That's probably fine just like that. So let me get these removed. Okay, I'm comfortable with that. It looks like everything is isolated, nothing should be shorting. So now I have to install my weird power cord and we'll ramp this thing up on the variac behind a dim bulb and just make sure that we get around plus 67 when we reach about 116 volts. I have this Fluke 87.5 hooked up to chassis and the positive power supply rail. I'm going to turn on my variac behind dim bulb and I'm just going to slowly ramp this up. So right now I have about 6 volts AC coming in, about half a volt out. Let's just ramp this up and see what we get. Let's stop here at around 40 volts. About 25 volts DC. Again, we're looking for about 67 once we get to 116 volts. And just looking at the current here, we're really, really low. There's nothing shorted here. I don't have any bright dim bulb performance. So this thing seems pretty stable. Okay, as I'm increasing this, there's not a change. That's because this is a regulated power supply. So from around 110 and up, there's a circuit that's regulating. So I'm feeding 121 in and it's basically stuck right around 67. So that means that this regulator is working down here. So anyways, it looks like that power supply is correctly configured for 120 volt AC mains, and we can proceed with doing some basic output testing. I'm going to be hooking up the speaker wire with some bananas. It should work well. And then I pulled this out of the back of the 33 preamp DIN to RCA adapter, so hopefully this will work for feeding a signal into the unit. So I'm going to go ahead and plug this into the DIN input. And that won't work. This is the wrong pin out. So that's a 5-pin DIN. I think what I need is a 4-pin DIN. So let me see if I can figure something else out. So I could connect the preamp to this device and test it, but whenever I'm servicing something, I want to completely isolate it. I don't want to be compounding issues. If the preamp has some sort of issue, I don't want to add that in and have it obscure the results for this power amp. So what I'm going to do is just use some clip leads and clip right onto the back side of this jack and get the signal fed in that way. Okay, I've got 3 different colored clip leads here. I'm going to use white for left channel, white for left, red for right, and green for ground. Now I'm just going to use an RCA connector to make these connections. So we're going red to red, white to white on the positive, and I'm just shoving my clip lead down here so that doesn't short out against the outer barrel here, and then I just need to clip on there. So should be able to get signal into it that way. Let's get this thing tested. Okay, I have the unit on at about 116 volts behind the dim bulb, and let's feed a signal into this and see what happens. So I have both my right and left channel, but it seems to be going a little bit wonky. I don't know if there's some hum or something there, or one channel's unstable. Let's increase the amplitude a little bit. It looks like the yellow channel is pretty unstable. I'm going to take this off of dim bulb and see if it does better without the current limiting. Okay, I just powered it on straight into the variac. It seems to like that a little bit better. Let's try a square wave instead. Same thing, it looks like the blue trace is stable, the yellow trace is all wonky. I think this is the left channel. Let me just double check. I'm going to pull the positive from the left output. Yeah, so my left channel is dancing all over the place. So this is a good baseline. We'll go from here, start troubleshooting and see if we can find any suspect components that might be causing this. So I just changed the scope to trigger off of the right channel, the blue trace, and now it's much easier to see that the right channel is working fine, left channel has an issue. So we're going to try to diagnose and repair this and get both traces to be stable. So right off the bat, we can eliminate a lot of this circuitry from being the root cause of the issue. Because the channels share a power supply and one channel is working, the power supply is not at fault. So these capacitors are fine, and we already confirmed that this regulator circuit was working. When we ramped the variac above 116, the voltage stayed at 67. So regulator circuit is good, transformer's good, these diodes are fine, and these capacitors are okay. So we're really just looking at one of these two driver boards and one of these two caps. Maybe the output transistors, but I doubt it. So I just need to figure out which one of these two boards is the left channel, and then we'll start hunting for bad components in whichever board it ends up being. I could probably look up in the service documentation which one of these channels is which, but I want to be absolutely sure, so I'm going to take this fluke, set it to continuity. So as long as there's low ohms, we're going to get a beep when these two contacts touch. So I'm going to connect to the channel that we know is bad, just the positive output, and that should lead right into one of these coupling capacitors. So let's just check here. There it is, 0.2 ohms. So that speaker wire connects directly to this capacitor. So on the other side of this capacitor, that will connect to the output of the driver board that we suspect. So that's a green and a white wire. The other one's green and red. It's got to be this guy right here. So let's check. Okay, and then it should not be this one. Got it. All right, so we're down to this board. Let's start hunting. So right off the bat, I'm just going to check these three electrolytic capacitors. They are super suspect. I'm almost going to guarantee that that's going to be our issue, is one of those three caps. So I'll grab the purple peak tester. We'll do an in-circuit test, and if they are inconclusive, we'll pull them and test them out of circuit. So I got my trusty Peak ESR 70. We're going to do some in-circuit testing on these three electrolytics. That's suspect. That one's okay. It's supposed to be 12 microfarad. It's measuring pretty high. Let's check this last one. That one seems okay. That's 60 microfarad with good ESR. So far I'm just suspecting this one. Do this again. Open circuit, low capacitance. Just for kicks, let's try that same cap in the good board. That one's probably also bad, but the fact that it measures differently has me thinking that that's our culprit. So let's go ahead and get that desoldered, and we'll check it again out of circuit. I don't really need to be super careful with documenting the polarity, because I'm not going to pull the cap out of this channel, and that'll give me a reference. This cap doesn't look terrible. It doesn't seem to be leaking anything, but it definitely does not look like the type of capacitor that should be staying in this unit. Let's test this thing out. All right, it's supposed to be 300 microfarad. Yeah, this cap's open. Let's replace all three of these electrolytics on this board and retest. Okay, I have those 3 caps replaced. Let's start it out on dim bulb. Okay, it started to freak out around 600 millivolts. All right, I'm bright in the dim bulb here. I'm drawing too much current. Let me switch this over to full power, but I think we're going to be in good shape here. Let's see how many watts this is making. And now it's funny, the blue channel is starting to shake. It's probably the bad caps that are still present in the other board. And that's my clipping. I can tell I'm a little bit out of adjustment because we should get even clipping on both channels. So right now it's clipping on the top. We should also have clipping at the bottom. So we can get just a little bit more output power here with an adjustment of the power supply rail. But right now I'm making about 35 watts per channel into 8 ohms, which I think is right around rated power. I did look up the specification and it looks like this amp is supposed to produce 45 watts per channel into 8 ohms. I'm not sure if that's one channel at a time or both channels driven, but what I can tell you is I know I can eke a little bit more performance out of this amp by doing a DC balance adjustment, but that'll wait till the end after it's completely serviced. So the next step, I'm going to go through and put together a parts list for everything that I would normally replace on something like this, and I'm also going to do some research looking up other people's restorations and see if there's any known to fail parts that I should preventatively replace. The parts just came in for the 303. I'm going to go with these caps from Kemet. These are 4700 microfarads, so our power supply will be moving up from 4000 microfarads of capacitance to over 9,000 microfarads. I've seen a lot of people use this value in here for the power supply without reporting any issues, so it should be fine for the regulation circuit. And then the coupling caps, I'm just using the same model so that everything looks nice in there. These are also 4700 microfarad. The original is 2000, so we're going to get, in theory, a little bit better low frequency response with a bigger coupling cap. So those will go in. Their diameter is slightly different than the original, just a little bit smaller, so I may need to wrap a little bit of tape around the bottom edge to increase the diameter so that they fit in the clips. For these boards, I'm going to be replacing these 3 capacitors, just like this board, with parts from stock. And then I did order in replacement trimmers. The original trimmers for DC balance, bias, and the regulator adjustment are this type here that they just don't hold up extremely well. They work fine right now, but I don't know how long they're going to last. And some of them are critical adjustments, so we'll go ahead and get those replaced as well. I'm going to start with the circuit boards. That way I can do some testing in between as I rebuild it, and then I'll do the big caps at the end once it's all working properly. I just noticed this teeny tiny axial capacitor. This is almost certainly going to be bad as well. I need to get these swapped out. See, it's rated at 64 volts. It's probably 0.64 microfarad, which I'd just replace with a 0.68, I guess, but let me measure this and see what it's like. Wow, 68 ohms of ESR. This thing's terrible. Let me look up the schematic, because that value is not really even close to what's marked on it, so I've got to find that thing in the schematic and figure out what it's actually supposed to be. So after looking at the schematic, it looks like this capacitor is the input coupling cap for the board. So it's the very first thing the signal goes through on its way to the rest of the circuit. So it's directly in the signal path. It's a pretty important cap. So I'll do a 0.68 microfarad stacked film capacitor in this position. I'm going to go ahead and replace these trimmer resistors. Normally I would measure the value of the originals as I pull them out to try to get them close, but in this case I'll just power this thing up on dim bulb, roughly set the DC balance, and turn the bias all the way down before ever hitting this with full power. I thought I was being really careful selecting the same series for these 2 trimmers, but apparently I got this part number wrong. So I ordered this set with the incorrect leg layout. So it won't sit in the board in the position that it originally would have. So instead of trying to hack something in, I'm going to go ahead and reorder that part. On the regulated power supply board here, there's a little tiny Zener diode, and this diode is doing its function just fine right now, but Zeners are more prone to failure than regular rectifier diodes and resistors and stuff like that, so I'm going to go ahead and preventatively replace that part. The part number on the Zener is LR120. I believe it's going to be a 12-volt Zener. Let me just throw this on my Zener checker. Yeah, right around 12 volts. So I'm going to find a 12-volt Zener that's rated at about ½ watt, and we'll put that in. I'm actually going to update this to a 1-watt BZX part. I'm going to go ahead and reinstall this little plate for the transformer, and then I'll move on to doing the green caps. Here's one of the original mounting clips and the replacement capacitor that I've ordered. We can see there's a discrepancy in the diameter. Now, I could have gone slightly larger than this, but I just couldn't find the value and quality that I wanted, so I had to go with something that was a little bit smaller. But I think I can add some diameter to this with some special tape that I like to use and make this work just fine with the original part, so that I don't need to drill extra holes in the chassis or put something in that's not original. I like to use this fiber style tape while working on stuff like this. It just looks really nice and it's easy to work with. So you can see how you could pretty effectively build up diameter with something like this, and once it's in a stack, it's got a little bit of flex to it. So this should work really well. So I'll go ahead and try to wrap one of these up and see if this will work. It's a little bit hard to see in the camera, but there is evidence of where this original mounting clip was. It's somewhere right around here, as far as where the top of it would have sat. Let me put this back on. So you can kind of see the dust line there. This would have sat somewhere right around here. So I'm going to use that as my gauge for where to put the tape on. So I'll just hold this cap up to this one and start the tape right there. Okay, so I'm just going to go around this can a few times to build up this layer, and we should be good to go to mount it into the clip. Let's see how that works. Yeah, that's about perfect there. So I'm going to go ahead and cut this. That, and then the ring go on just like that, and that should tighten up great. Yeah, that'll work well. Okay, so I've prepared all 4 of the capacitors. Now I'm just going to mount them each in their clips so that we can reinstall them in the chassis. To make things a little bit easier on myself, I'm going to mark the positive of each one of these so that I can get the orientation correct. Before I tighten everything down, I'm going to use a caliper to set the depth and then, get the rotation as close to 90 degrees as I can, you know, more like that. So I'll go through and fine tune these before I tighten everything down. Okay, I've got all of the capacitors mounted and tightened in, set to the same depth and the correct orientation, so now it's time to reconnect them. All right, this is about as far as I can go on this thing right now. I'm just waiting for these final trimmers to come in. In the meantime, let's take a look at the 33 preamp. Looking at the back, it has these interesting flip-up covers, which makes me think that these are cards that can be pulled out. I don't want to give it too much force, but let me just check. This says disc adapter. This is going to be like a phono stage. Yeah, this looks like it's coming right out. Interesting. My guess is that you can plug in different phono stages, but it looks like you could technically rotate it into different positions. So that's that. Let's see what this tape adapter looks like. I don't know if this is like a record amp or what. Record, replay, replay. Interesting. Okay. Kind of like that modular design. A little bit difficult to find the socket. I'll wait till it's open back up. All right, so I've got 2 screws here. And my guess is that allows it to slide out of the chassis. I might need to remove some knobs. So let's take out these 2 screws and see what happens. Just notice there's a little bit of a chip here, and that kind of intersection is now floating. So I think this piece of metal is just a shell with some feet. Wow, that's a long screw. Oh, that was easy. Ooh, repaired by Planabox in 2015. Well, that's a surprise. I'm gonna have to look at this. I wonder if, oh yeah, I can see some of these caps were replaced. Well, this might not need a whole lot of work, but it looks like it's card-based, which is sweet. So let me see. I can see some Nichicon Muse down here. Let's see if this pulls out. Does that look like a header? I don't know if that one comes out. These are definitely in sockets. Let's pull one of these out. Oh yeah, Benick. Oh, somebody put some nice parts in here. This is a Elna Seraphim. This red cap looks nice too. Another Elna. So someone's already been in here doing some really high quality work in this unit. So what I've got to do in here is probably going to be minimal. These axials, I can't tell if these have been replaced or not. I want to see if I can get this out, if that's a card. Yeah, that looks like another socket. Let me see if I can jiggle this thing out. Okay. Looks like Nichicon HE and Nichicon Muse. It looks like the transistors have been replaced as well. Somebody did an extensive overhaul on this piece. So the complaints that I have from Pedro are mostly related to the connectors. So we'll see what I can do about that. So this is a DIN to RCA plug that he sent along with the unit. And if we go into the disk input, It's a little bit loose in there. It's not bad, but it's a little shaky. If we go into the tape replay, which is probably never used, let's see, is that the same pinout? That's much more snug in there. It might look like it's vibrating, but I can just tell the pins are making better contact. This is not bad. Yeah, so we'll see. Try the output. The output's a different pinout. That's the 4-pin one that goes to the 30 or the 303. These all seem pretty good. I might just need to clean the controls in this thing and send it on its way. So it looks like they did some new suppression caps on the switch. This switch looks brand new, actually. This might be a completely new level control. The rest of the controls appear to be original. I'll have to see. I don't know if anything needs to get replaced on the bottom boards. It looks like mostly just resistors and switches. I guess those would just slide out. But wow, what a beautiful build. I'm starting to like these quad pieces. They're really built to be serviced, and they're built really clean. So when I picked the preamp up from Pedro, one of the things that he wanted me to take a look at was the balance control. He said that when he panned it all the way to one side, it wouldn't mute the opposite channel like a normal balance control would work. Instead, it was just kind of subtly shifting the image left and right. So I took a look at it, and what I found is that on the front, you would think that it's a fader, but it's actually not. There's a mechanical linkage that connects to a conventional potentiometer right here. So if we look at the flat side of the shaft here, when it's all the way over to one side, when we bring it over to the other side, you can see it's not nearly making a full rotation of that control. It's just kind of working within a small range within that control. So that explains why taking it all the way over to one side doesn't mute out the other channel. Okay, I've got the quad connected at the bench. I just used the DIN to RCA adapter to feed a signal into the radio 1 input. And then this was a cable that was sent along with it to connect to the amplifier. I just came out of it with my clip leads and went into an RCA cable. Okay, so we can see I've got a red and a yellow trace here for left and right channel. This is with the volume control all the way up. It's almost like there's an extra rotation at the top where we have a little bit of imbalance. It looks like it's pretty good in that range. So that just means that the tracking isn't perfectly identical between the two gangs. But for the majority of this range, this thing's tracking really, really well. There's a little balance slider on the front underneath the volume control. And if I rotate that, or not rotate, if I slide it left to right, we can see the balance is working and it's nice and clean. I'm just going to even it out here. There we go. And I'm just going to be testing it right about here. Let's change this over to a square wave. Right now the tone control is defeated. If I push the 5K button, we'll engage the tone. I can change the contour of the filter here with the contour control. I'm just going to leave this in, I guess, the flat position. And then this is my treble, cut, and boost. Looks like my channels are fairly consistent. This is the bass. You can see there's a little bit of discrepancy, so that means that the carbon tracks of the potentiometers are not perfectly aligned, but it's only in one range. You'd have to be boosting the bass pretty significantly to get into this area where they're not even. But at 60%, they're already converging and looking really good. So this is an interesting device. When I have the controls all flat on the front, I get very, very flat response. If I defeat the tone, I get a little bit of a tilt. That's with the tone circuit engaged. This is with it disengaged. In any case, this thing's working great, at least the line stage. I'm going to test the phono stage next, but I don't need to do anything on this piece. The discrepancies that we're seeing are related to the controls themselves, and there's nothing I can really do about that. So this thing is working really, really well. Let's feed a signal into the phono stage and see what the RAAA tracking looks like. Okay, I just reconfigured my patch panel. I'm feeding my test signal into an inverse RAAA filter, coming out of that filter into the disc input. Let's see if I can get this down here. So that signal is going into the disk input here, and then my output is still connected into my PAA1 analyzer. So let's take a look at how the phono stage is performing. Okay, all settings are equal. I've just selected disk instead of radio 1. My signal is much lower than it was on the line input, which is to be expected, so I'm just going to raise the amplitude here of my test signal, and we can see that this phono stage has excellent RIAA tracking. So that's really all I need to test on this thing. It's really performing well. Flat frequency response, phono stage works great. I think the last thing to do is to pair this up with the 303 and see how they work together as a pair. The correct trimmers just arrived for the 303 power amplifier, so I'm going to go ahead and get those installed. In hindsight, I probably should have replaced one set of trimmers at a time. Because I've replaced all 5, I need to monitor every one of these parameters simultaneously at power up to make sure everything is safe. And some other things I noticed looking at the manual to figure out these test points is there's many versions of this amplifier. There's a service bulletin for if the caps are facing the direction that my original ones were. They're supposed to be inverted 180 degrees and the connections are supposed to be on the top. And a terminal strip gets added. None of that's here. I didn't see that service bulletin in time, so I've already wired it up how it was. But the bottom line is that there's various versions of this amplifier and not all of them match the service literature. So I think I have everything hooked up correctly. I'll explain where my connections are going and then we'll fire this up for the first time and see if it works. For the connections, I have the 87.5s measuring current, and I basically just disconnected the positive power supply from the capacitor and put the meter in series. So that's how I'm measuring the bias. The center point adjustment is just coming off the coupling cap, and the regulated voltage I'm just measuring off of the power supply bank. So I'm going to plug this in a dim bulb and just ramp it up slowly and we'll see what we get. Okay, starting to see my voltage here. There's not going to be any bias until this comes up a little bit. So the first thing that I want to do is get it to start regulating, and then I'll make the adjustment at like 122 volts or something. It's around what my outlets are here. So right now I'm concerned that my bias is going to be too high. So I'm going to go ahead and make an adjustment on the bias on each channel and bring them down. I'm going to flip this meter up so that we can see it. So I'm at about 6 milliamps there. I just want to turn this bias all the way down. So I'm going to try to rotate it left and see what happens. Okay, so it looks like clockwise takes it up. So I'm just going to turn this control fully counterclockwise on both for a minimal current draw. Okay, I'm going to continue ramping it up. We're approaching 67 volts, and I changed both the Zener and the trimmer, so this is almost certainly going to be off of 67. So right now I'm adjusting the regulated voltage. Let me take it up just a little bit more. And when I rotate it clockwise, the voltage is actually going up and not down. This is supposed to be 67 volts, so something is not working properly here. So I need to look at the trimmer that I changed and the Zener. It's possible I put in the wrong value Zener diode or something. So I loaded the original parts back into the regulator, the Zener diode and this trimmer resistor, and it still had the same issue. So I ended up checking back to what I had done over here. I think one of my test leads was bad, so I replaced that and now I've got it adjusted and it's regulating. So I'm going to swap in the new parts again and retry it. Okay, I have the replacement Zener diode and trimmer capacitor installed. I'm powered on. I'm at about 71 volts. I'm at about 112 in, and if I rotate this clockwise, now we have adjustment. So it was definitely something to do with that clip lead, and that can happen from time to time where inside of the clip lead, maybe if something's hanging on it and it gets dropped and it stretches the internal conductor, it can kind of make contact, but not really. So once I put in a good clip lead, it solved that. So now I'm going to ramp the mains up to 122 and our regulated voltage should stay solid here. I don't think I'm going to get much closer than that. So we'll call that at 67. Next up, I want to do the center voltage and the bias. The bias right now is stable at about 7 milliamps, but I'm measuring in the amps mode. Now that I know it's safe and it's not going to blow the fuse inside of my meter, I'm going to switch this over to milliamp mode for some more accuracy, and then I'm going to come off of dim bulb and connect to full power. For the center voltage, we want it to be exactly half of the power supply rail, and even though I just adjusted that to 67, it continues to drift a little bit. So I'm going to plug this straight into a outlet and do these adjustments. I've switched these over to the milliamp range, and they're starting to come down a little bit. So half of 67 is 33.5. So I'm going to adjust the center point of the right channel here to 33.5. And these voltages might interact a little bit, so that's why I like having multiple meters and to do it all at once. So that's 33.5, and I don't have enough meters to set both of these simultaneously, so I need to move this connector up to the other output. Okay, that one's low. That's this adjustment here. And this is just a rough setting. This is all the service manual says, but we're going to look at this when it clips at full output power and tweak this for the highest output. So this is a good starting point, 33.5, so we're sitting at the middle of the rail. We can see my regulated supply has come up a little bit. I'm just going to slightly tweak that. So to go down, I want to go a little bit clockwise. You can see that shifted just a little bit. $33.5. Okay, and I think I'm going to leave the bias right there. The only problem is this is the control turned all the way down. It's all the way to the left. If I take the bias control and I tweak it, let's see, now it's starting to go up. I think what I'll do is I'll just take it down to the point where it stops changing. It's around 8.5. The manual says to put this between 5 and 10 milliamps, so we're kind of right there. I'm going to go 8.6 milliamps. That way I'm within the adjustment of the control. Do the same thing on this one. 8.6, 33.5, 67. I'm just going to double check my other center voltage and we should be good. 33.5, yeah, this is looking great. So I'm going to go ahead and power this down. I will solder the connections in and then we can do an output power test. So just for some clarification on my connections, this was the wire that leads to the regulated power supply. So these three wires were originally soldered into this cap, but I needed to interrupt these two in order to measure the DC bias. So this I was just clipping into here, and my original black test lead I had just wasn't making good contact, so it couldn't regulate. So that was what was going on there. And then to measure the bias, this is the positive power supply that goes into each one of the driver boards. So I was just measuring, well, not really measuring, I was putting the meter in series with the positive power supply and the driver board, and then through the meter measuring current that was flowing through this connection. I've got everything reconnected, just as we did when we did the initial test, so I'll come up to the equipment here. And right now I'm on dim bulb just to make sure that everything's okay. And it looks like we have both channels. Let's just ramp it up a little bit. And right now my bulb is getting a little bit bright and we're getting some limiting there. So let's back it back down. All right, I think that's safe to throw on full power and we'll see how it does. Okay, let's take a look at the performance. So if I feed a sine wave into both channels, right now I'm making about 8 watts. Just slowly increase this until we get clipping right about there. Back it down. We can see in the right channel it's a little bit higher. Just a very slight channel imbalance, but as I raise this up, we'll see a point where the distortion starts to rise. And if we go a little bit further, we'll probably see clipping. Yep, so you can see a little bit of dancing on the top of that blue waveform in the right channel. and the distortion continues to rise. So this is making 35 watts per channel into 8 ohms, or more like 33, both channels driven. If I remove the right channel and we just do the left, let's change the trigger. Let's see if we can go any further when only one channel is being driven by the supply. Distortion starting to rise, and we've got some flat topping on the waveform there. So right now this is at about 40 watts, one channel driven. So earlier we'd set the center point at exactly half of the rail voltage, and that's enough to get us close, but not enough to get maximum performance out of the amp. So I'm going to see if we can eke a little bit more performance out of this by adjusting it with the test equipment. I've got the boards flipped down here so that I can come in with the trimmer and adjust this parameter. So as you see the waveform changing on the scope, that's what I'm doing, is adjusting this balance trimmer here. All right, let's go ahead and power up, and we'll feed in the signal. Okay, let's take these both up into clipping, right about there. I just want to get it right on the edge because I don't want to stress this out too much. Okay, so we can see both channels clipping here. I think this is going to be the blue trace. So you can see as I move through this, I can move the flattening from the top half of the waveform to the bottom. So centering the center point between the rail and ground got us close, but not quite. So I'm just going to tweak both of these to get it to where we are kind of in the middle. And then let's go a little bit higher. And we really just want equal flattening on each half of the waveform. Right about there. Let's take it down a little bit. Right about there. So you can see the distortion dropping. It's stable here. So we've got a few extra watts out of it. Let's try one channel at a time. Yeah, I can't see us getting more than about 40 watts out of this thing. 30, 38, 39, 40, something like that. So there's probably a little bit of funny business going on with their specification sheet. But anyways, we got this thing optimized. It's making 37, 38 watts before it starts to clip and distortion increases. I'll get these cards clipped back in, and then we connect it to the 33 and make some music. I'm running the 33 and the 303 together for the first time, and running in this configuration revealed an issue in the preamp that I didn't notice before. If you recall, a bit earlier I had a suspicion that this volume control might have been replaced at some point in the past, and now I'm pretty sure that's the case. I looked up some pictures of these controls. It doesn't match what an original one would have looked like. It's a lot brighter and shinier than all of the other controls that are in here, and I think I have an idea of what happened. On this specific 33, somebody has added a hole to the chassis that's not supposed to be here. My theory is that at some point in the past, the original volume control started to act up, and somebody replaced it with a straight dual potentiometer with no integrated switch. And then they drilled a hole here to install a front panel power switch. That's my theory anyways. Then at some point in the future, somebody asks this company Planabox to take this thing back to stock. They order a replacement control from Quad, install it, and to fill this hole, they move the lamp from the Quad light over to here so that you get an illumination. It doesn't look like a random hole that's not supposed to be there. It also looks like this panel was painted at some point in the past, or we're missing the little indicator line that should be here on the volume control. So with that in mind, let's do some more testing. I'm going to show you what I discovered with this replacement volume control. I have the 33 powered up and the volume control is cranked all the way. What we're looking at on the oscilloscope here is the output of the 303 power amplifier, and we're also looking at the amplitude of the left and right channels on the meters here on the PA81. So with the volume control all the way at its maximum, it's basically out of circuit. And we can see just a slight channel imbalance here. I'm going to take the balance control and just slide it until these channels are basically right on top of one another, right about there. Next, I'm going to set a dB reference on the PA81 so that we can compare the channel balance. So the issue that I'm noticing here is that this volume control is not consistent throughout its range. Even though it was replaced, it's still not tracking properly. So let me demonstrate that now. Okay, I'm just going to slowly ramp down this control, and what we're going to watch is the difference in the channels on the oscilloscope here. So right now everything's looking pretty good, but once I get down, this is around 50%. See, it gets really wonky in this range, and it's kind of just how the carbon is deposited onto these wafers. I'm going to try to get it to the point where it's measuring the worst. It's somewhere right about here. So now what I'm going to do is I want to use the dB feature of the PA81, so I'm just going to take the test signal and reduce it until one of these needles gets to 0 dB. We're in the red scale here. So the right channel is at 0 dB. If we look at the left channel, it's about -2 dB. Now, from what I've read, if the deviation gets greater than 1 dB, it can be audible. So in this specific range of the volume control, it's at like 52%. You will perceive a bit of image shift. It can be compensated with the balance control, but it's kind of inconvenient to do on this model, especially because it's kind of hard to grab it. I use a mini flat blade screwdriver to change it because it's kind of hard to get your finger in there to adjust that linkage. But anyways, this is what the imbalance is looking like. Let me keep going down and we'll see something even more interesting. So notice how the yellow channel is at a slightly higher amplitude than the red channel or the left channel. If we lower this down, now they're converging. If you look at the needles, they're almost identical up top. But as we continue to go down, the red channel becomes greater than the yellow channel. We get down to the next range here and we'll see it. So you see how now the red has kind of overtaken the yellow here? It's not as bad in this range. Let's take a measurement on this one. So I'm going to do the same thing. I'm going to reduce my test signal until the right meter gets down to 0 dB, and then we'll look at the difference. So I'm at 0 dB right there, and then the left meter is at about +1 dB. So that's showing the difference there. So the conclusion here is that this volume control, the two gangs don't track extremely closely, and in certain ranges you might get enough image shift that it would be noticeable in listening. So I just wanted to point that out. It's something I noticed about this control, and I didn't catch it when I tested the preamp by itself because all my tests were done with the volume control 50% and up. I'm going to go ahead and stop this video right here. The next step is listening tests, and I think it's just going to work out so much better in Pedro's place, so we'll wait a little bit to do those. The tests that I'd like to complete are first just general listening tests. So Pedro has a pair of ESL57, so we're going to do the 33, the 303, and the ESL57. So that should be pretty fun in and of itself. But the test I'm really curious about is taking this preamp into that 50-52% range where we saw that maximum channel deviation. And I want to see if I can actually perceive it. I've always gone by what I've read, which is like 0.5 dB to 1 dB, you can start perceiving a difference. I have no idea if I can actually hear it. So that's going to be really fun to set it to that range and see if we can perceive the shift. Thanks so much for stopping by the channel and checking out this video on the Quad 33 and Quad 303. If you like this content, I'd invite you to like and subscribe. And if you want a more in-depth experience kind of behind my shoulder at the bench, be sure to check out my Patreon page. I'll leave a link in the description. Thanks again. I'll catch you on the next one.